Hello. Today I'll be walking you through a very simplistic overview of the project I have worked on through this file called basescene, which, among other things, also contains the basescene as represented here. Apart from that, though, it also contains the spatial representation generators, but in the sort of raw format. Because ordinarily you would not use these like this. Instead, you would use them through a spatial bounds volume. However, using them like this just to run these tests is a lot faster, a lot more efficient, and generally little bit easier. So that's where they are done, not using that. But this can lead to issues if, say, you were to let the generator go out of scope. So that is worth taking into account. You should not use this if the generator can go out of scope. Or you should not do it this way if the generator can go out of scope. Instead, you should use the spatial bounds volume and then stitch the generator into that. Apart from that, let's get started by showing you how the visibility graph works. The visibility graph is basically very simple. You pass in the terrain. You don't need to pass in the OBB and min and max, because as you can see, if I go over to this, it has no OBB min and max flag. These flags basically dictate how you can interact with it, as best seen by the grid generation class. One file. And as you can see, this allows us to pass OBB and input. If we try to pass OBB input for min and max and it doesn't work, it'll just return out false here saying something went wrong. Anyways, we start the generation as a join process because it is multi-threaded, but we start it as a join process because, again, if something goes out of scope, it'll break things. It'll also ruin our ability to get an accurate measurement of time as well. And we also delete the nodes here because if you don't delete the nodes, it is going to cause a memory leak. These nodes are pointers that are created and they do need to be deleted because of that. And as you can see, we got a visibility graph. We can also change the extent, modify a bunch of other parameters, and then just regenerate it, should we want to. So moving on, we're going to show the grid class next. And I'm going to just, real quick, this basically just shows the connections. Actually, it might be a good idea to show the connections. Yeah, I'll do that. But it shows the connections between the different types of nodes. As you can see, this green node has these red nodes as its connections. This class can also work with different kinds of shapes, and this is where we set the base shape for it to use. So I'm going to make this into a parallelogram because that's the easiest thing to do. You can also make it into a hexagon, it does support that. And now, as you can see, it works as a parallelogram. All these are parallelograms, which is nice. You do have to specify this though for parallelograms. If you were using just oxygens, you wouldn't have to specify the scale multiplication. Instead, you just type shifting pattern equals true. Well, you set that to true, should I say. Lastly is the nav mesh. The nav mesh is based upon Valve nav meshes, except I did modify the first stage of it so that it can generate over more terrain than the Valve nav mesh normally could. it can go over gaps and stuff like that, which is very useful. And as seen here, it does go over this gap. And I should also mention this white space outside of all the black lines, that is technically empty space. The grid generator will basically generate just fine on empty space, so too will the visibility graph. If you have it configured that way, it will do it just fine. But this does actually need to generate on solid terrain. It will not generate over empty space. So on solid terrain, we have this and this. And these are basically the area it thinks you can navigate in these, on top of these objects. However, it's worth noting it's not 100% accurate. As you can see, there is a big gap of area which you could navigate here, and it doesn't represent that. It doesn't represent that because the method I was using to make it so that it can cross things like the gaps also results in there being some inaccuracies in the ability to represent things at a certain scale. By this I mean this small gap here. It's too big. It's hard to explain until you dissect the stages, but basically it's like splitting everything into a bunch of cubes, then it reforms everything into one giant cube. So all this has been split into a bunch of cubes, then it's reformed this into a giant cube, but in the splitted cube, this part just went beyond the bounds of the object and it got deleted because of that. And then the merging part, it's all been brought back together, but with this area now deleted. And that's it for work I've done, pretty much. Got a bunch of different spatial representations. They do support connections, as I demonstrated with the grid graph, but so do all the other graphs. In fact, in the edge graph, you can also see the connections. Not the edge graph, the visibility graph. You can see the connections, it's a line between them. It's just the same color, it's not green or red. But they all support connections, they all do work as the thing that they are intended to work as. Generally, I have no flaws with it. I can't think of any problems with it. Apart from that visibility graphs sometimes can have inaccuracies. Again, this is also a result of the initial method I used, but it does allow it to be more capable in ways that the base Valve nav mesh generation system isn't. And that's it. Goodbye.